Hello everyone, just a reminder to check out ReproRehab, where you can learn how to utilize reproducibility principles in your rehabilitation research. Today I'm going to be talking about food access as derived through the U.S. Department of Agriculture and how to be able to get data from about food access across the United States and be able to merge it with your own individual participant data. And so, specifically, food access, as defined through the Economic Research Service, is consumer choices about food spending and diet that are likely to be influenced by the accessibility and affordability of food retailers. This includes travel time to shopping, availability of healthy foods, and food prices. So some people and places, especially those with low income, may face greater barriers in accessing healthy and affordable food retailers, which may negatively affect diet and food security. So in terms of rehabilitation, nutrition and accessibility to high quality food may be one that might influence the ability for a person to potentially have optimal rehabilitation. And so it's actually very easy to get these data. If you just go to the following URL, which I'll have within the R script, all of the food access data will just be within this single Excel file. And interestingly, though, the way that these data are broken down are based across are generated as an atlas on the 2010 census tract polygons. And so why this is interesting is because we're talking about a very kind of granular way of being able to determine food access for any particular person dependent upon their census tract. So it's going to be interesting in terms of how we're able to take zip code data and really be able to match it to specific census tracts. And so allow me to kind of give you a quick visualization of how this is going to look. So as you can see, across the U.S., these green areas here represent individuals or individual census tracts that are low income and low access, with people who live in urban areas at least 1 mile away and from food access, and people who live in rural areas is 10 miles away, and that's denoted in the green here. So the size of these tracts, and each of these green ones represents a different tract, is going to be kind of interesting as we kind of look at how granular versus broad a lot of these areas are, and how much that's going to change, not just from state to state, but also within more urban areas versus more rural areas. So food access is really going to be dependent upon where an individual lives, which makes these data a little tricky to kind of comb through at first. So all you have to do to be able to get the data onto your own computer is just download this file here. And so I want to give a quick primer again about the difference between really what we're talking about as a census tract versus kind of county lines versus, generally speaking, zip code areas as well. So I'm gonna run all this data kind of live as we go through it. What I'm going to demonstrate here is that you only need these three libraries, so you need to load these first. And we're going to look at here an example state of Alabama. And so what we're going to do here is we're going to look at Alabama based off of 2022 data, looking at median income across census tract. And we'll go ahead and plot that in R here. And so what you can see pretty quickly is that there are a lot of tracts, and obviously in the areas where there is more densely populated areas, those tracts are going to become much smaller than the areas that are more rural. If we look at this at the county level, we can see that if we were to just try to determine food accessibility based off a county, these are square miles of many hundreds of square miles within each county. And then again, if I bring up just looking at zip codes within Alabama, and we compare that to census tracts, even though zip code gives us a little bit better resolution, better than that of county, you can see that within specific urban areas, there's going to be way more census tracts compared to that of zip codes. So the proportion of exactly how well these things line up, as different tracts may or may not overlap with different zip codes as you kind of work through these things, it's going to be only really a good approximation, or hopefully a close approximation, to an individual's food access based upon their zip code as it relates to where they are within their census tract. There's really no one-to-one ratio between matching a specific zip code to a specific census tract. Okay, especially if we're talking about 5 zip codes. All right, so where are we? Okay, and just as a reminder, so there are about 84,000 census tracts within the U.S. There's about 41,000 zip codes, and overall only about 3,100 counties. So in order to really be able to figure out what's the best resolution we need for different kind of environmental and socioeconomic variables that we're trying to query from these government agencies, it's going to be very important to be able to determine if something at the county level is too general, or versus something at the specific census tract level is perhaps too specific. So as we work through these data now, I'll show you exactly how my approach to be able to work with the food atlas data for food access through the USDA with my own zip code data. So I'm going to load my data, my zip. Again, it's going to have just 5-digit zip codes with state abbreviations linked to it. I'm going to pad any 4-digit zip codes with a 0. And now what I'm going to do is I'm going to use the zipcodeR library, which I loaded up here at the top, to be able to get to use my 5-digit zip code to essentially get a kind of object or a data frame here representative of that zip code. And so as you can see here, because I should be running all of this data as I'm running through it. I'm talking about this particular entry, I can see that I get a lot of demographic variables such as mean income, household value, and population, number of housing units. So these might be things interesting to compare to food access. And what I'm going to do now is I'm going to take a lot of the variables from here and be able to put them into, basically concatenate them into my kind of parent zip file from my participants and get county data, latitude data, longitude data, median household income, median home value, population density, population. And I believe all of these values here come from the most current 2020 census data. And we're going to basically use these to compare to our food access data, as the food access data also has population and median income as well. And so this will give us kind of an interesting proof of concept about how well we're able to match based off of zip codes we get from zipcodeR to the census tract data that we're going to get from the food access database. And then what I'm going to do is use a specific function within I'm going to run this while I talk about it. A specific function within the zipcodeR package called getTracks, where essentially all I have to do is put in my 5-digit zip code as a character, and then I'm going to take all of the available tracks and put it in the row associated with that specific zip code as zip tract. Now what's going to be interesting about this is that when we look at, say, zip tract of this instance here, we're not getting just one track. We're actually going to get multiple, as you can see here. So in regards to what these data actually look like, when we look at zip tract, each one of these rows is going to have actually several values for different census tracts that exist within that 5-digit zip code. And using this census tract data that we got from getTracks from zipcodeR is how we're going to try to identify the census tracts within our zip code that are going to be matched within the census tracts within the food access data. Okay. And so the total number of variables I have in here now is I have zip 5, state, county, latitude, longitude, median income, median house income, pop density, population, and zip tract. Now I'm going to go ahead and download my food access atlas. And I'm going to change and make sure that the first variable name is census tract, which it is. And we can quickly look at the dimensions of the Food Access Atlas, and there's 72,531 observations, and this is the total number of different census tracts. So if we want to go ahead and just look at the kind of the top lines of this data set, there are 147 variables, so there's actually quite a bit of data that we can actually mine from here. And here are the different census tracts. And so I have the actual Food Access Atlas here within the Excel, and it comes with a data dictionary for all of the different variables, and then the variables on a separate sheet are all listed here. And so here are all the census tracts, the state, the county, some general demographic variables. So here they use the population from 2010, interestingly. And I think that's because they have not quite updated this atlas with the latest 2020 figures. So this is an example of how some things might be lagging depending on which type of data you're grabbing from whichever source from the government. And so we're going to basically compare the population of 2010 to the population we've got from the zipcodeR package, and we'll also compare the median family income to the median household income from the zipcodeR package as well. And this will give us perhaps an idea of just how accurate or far off the data that we're getting for some of these variables are to that of the other variables we're grabbing from other packages. Okay. And so, one thing to reiterate, I'm using try-catch here because essentially if I put in a zip code that does not have a specific census tract, perhaps something was put in incorrectly or it's a zip code that just doesn't exist within the US, it will throw an error and basically stop the loop. So I'm going to basically have it bypass whenever it has that error so that it can keep running without me having to worry about it, and essentially the anything that is an error is just going to be filed as a NA, not available value. Okay, so now what I'm going to do, now that I have my FAA data set loaded, I am going to now select the names of the variables within the Food Access Atlas that I would like to match to my specific zip code data, and I'm going to create basically an empty matrix to be able to then store all of these variables in as I kind of iterate through all of my zip codes within my data set. So the ones that I'm looking at are poverty rate, median family income, LILA tracks 1 and 10, which is the same one we saw on the map. Some of them they have to do with vehicle access and also being low access population of at 1 in 10 miles, low access population of share at 1 mile, the low access share of the population that is white at a half mile, the low access population that is black at a half mile, I forget what these are, the population 2010 and low access population share at a half mile as well. So there's a lot of things you can grab from this, but these are just ones that I'm interested in that I want to be able to look at a little bit more. So here I've created my empty matrix here, so I've pre-allocated this, so as it runs it's basically going to input all of the values here for all 10 of these variables as it runs across each zip code within my participant data set. So I've set it here again for the total number of zip codes I have. Again, this is a hard-coded way of doing it. It really should be dim zip code of the first dimension. And I'm going to use try-catch, and then I'm going to basically match my zip code to the specific census tract, depending on whichever iteration within the loop I'm in. And so the way that this is going to work is that within FAA, I'm going to ask it to identify across all of the census tracts within AA which of them are matched to, at every index, the specific census tract that I'm indexing here. So I'm going to say I equals 1 to kind of walk through this step by step. And I'm going to be using double brackets here because within my zip tract variable, as I demonstrated, they are in fact a list of data. And so this is stored within my data frame at each row as different lists. And so what I'm going to be demonstrating here is that if I kind of show this variable, I have multiple multiple census tracts related to the zip code that I had previously matched it with in the above loop. And if I just were to just run this here, what I'm going to get is a very a large matrix of all of the rows and columns of FAA, that all of the rows that match this saying true or false across all of the columns that I've specified here in my FAA data set. So just to run this inner part first, as I can see, what it's going to return is just the rows that match my zip tract, and it's going to return then all 10 variables that I have within A names. I know there are 11 variables within A names. And then what I'm going to do is I'm going to convert this to numeric. And as you can see, I get some warning messages, but nothing crazy, because essentially it had to convert these nulls into NAs. And then outside of that, I am then going to get the means, the column means for each of these variables, while ignoring or removing any NA values. So when it takes the mean of this column, it's just going to give me the mean of the real numbers. It's not going to return just an NA because I have one NA there. Now if I run that, I'm going to get individual values for each of them. So then when I then put it into my kind of temporary matrix called A, that's going to be collecting all of my matched census tract data from FAA to that's matched with my zip code, my participant zip code data. It will kind of build it iteratively as I do that. So if I run this whole line all together, you can see here within the first row I have all of those variables now populated with some value. And this is perhaps a much more efficient way of running this compared to trying to run separate try-catch statements for each of these variables. This I think makes the code look a little bit shorter, a little bit cleaner, although this is a very monstrous type of line here. To be able to understand what exactly is happening can be quite difficult. But really all you have to do is just update this list with what variables you want, and it will generate a matrix that will have those specific names in it for the total number of with the total number of columns per the number of variables you're looking for, and then populate it accordingly to the dimensions of your zip folder, of your zip code participant data frame. And so I'll run this. Runs fairly quickly actually. And I'm going to convert it to a data frame, so that makes it easier for merging it with my zip file. And then I'm going to look at exactly how well was I able to get all of the what percentage essentially was I able to get of real values within all of these data. And so overall I was in between 75%. I was able to get a value for 75% of my zip code participant data to about 80%, which is not too bad. And so I'm going to merge that, and I have a new myzip file, myzip data frame. We'll look here. You can see now I have all of those variables that I had listed here are now part of my zip file. And now I'm going to basically do some sanity checks to be able to determine how well my matching actually does, or really the validity between the data that I have now kind of combined and averaged across in my zip file, in my kind of generation of the data here, to that of the participant zip code data that I got from the zipcodeR function here. And so what we're first going to do is look at the median income of the that I got from the zip code R function library, and the median family income that I got from the food access data set. And I can see there's a pretty good agreement. So essentially the axes seem to line up. There's a little bit potential bias, I think, that the median income is a little bit higher. As you can see, here's the one-to-one line. It's a little bit higher for the median family income I got from the food access data set compared to the zip code R data set. But when I then look at it for population, between the population that I got from zip code R to the 2010 population within the food access atlas, I can see that although there's a positive trend here, it really doesn't match up as well. And so this might be because the zip code R population is derived from more current data from the 2020 census versus that of the 2010 population data derived from the food access atlas. So this is something just to keep in mind, and that it seems like there's good agreement I saw across some variables, but not so much across others. So just to keep in mind as we're kind of working through this then. This is basically data within the food access atlas that is over 10 years old, and just as another kind of verification of these data, this was released in April of 2021. So why they're still using that data is probably because by this time the census was just concluding. So hopefully there will be a new release where this data will be updated with more up-to-date population numbers. So now we're going to look at a couple of test cases here where I'm interested in generally how well does the data that I have now gotten from my overall matching scheme that I have here to that of the relationships that we can observe within the total data set within the food access atlas. So I'm going to look at the relationship between poverty rate and the low access population that also does not have a vehicle at half a mile. So the total share of the population that is a half a mile away from food access that does not have a vehicle. And what I can see here is that essentially as the poverty rate goes up within my data, the low access at a half mile and no vehicle also goes up. And so if I were to run a quick model of this data, what I can see here is that the intercept is 0.96. So I'm going to change this here, and basically what I'm going to do is I'm going to plot these data with this regression equation here to that of the actual data that we'll observe within the entire data set. And what I want to see is how well does this regression line that I'm seeing from my data how well does it overlap or match the relationships that I would observe within the actual data here. So it kind of gives me an idea of how representative is my data compared to that of kind of the overall data set from the food access atlas. And so what I'm going to do is I'm going to plot the my regression line in red, and then I'm going to plot the regression line for the entire FAA data set in blue. And what I can see here is that they're basically overlapped with one another. And so the same trend exists within the same intercept and slope of that of the FAA to my zip code data. So this demonstrates that overall generalizability of my data and these relationships that may exist to that of the data across the entire atlas. So I think that's a good kind of sanity check in terms of being able to understand just how generalizable are your data. So next I'm going to be looking at a couple of other things here as well, which I think is of interest and potentially may be able to kind of show how these data can be used as a function of understanding health disparity within research. And so what I'm going to look at is the low access population that is a half mile from a half mile away. So this is going to be a percentage of the population that is a half mile away from food access to that of the poverty rate within my data. And what I can see here is that basically as the poverty rate goes up, then the share of people who have that half mile low access mark is lower. And then if I were to look at that again within across the entire FAA, and these take a little while to render, I see generally the same thing, but obviously a lot of heterogeneity in the data. Now, interestingly, what are some things you can actually look at is looking at the population share that is white within a census tract compared to that of the poverty rate. Within my data, I see something similar to what I saw across the entire population. And the same is true within the entire data set of the FAA. Interestingly, when I look at it as far as the black share at a half mile, I see a positive relationship. So that essentially, as poverty rate increases, the share of the census tract that has is greater for among black individuals at a half mile of food access. And so this is actually interesting in terms of now what I would consider that we're seeing opposite relationships between the black access at the same distance to that of white access. But this could be perhaps an artifact of just my data. But of course, when we look at this again within the entire data set, we see the same positive trend. So we see a negative relationship when we're focusing on the white share of the population versus the black share of a population. And when we then kind of look at this as the relationship between the black share of a population, the white share of a population with low access at a half mile, and then we code it with poverty rate as a color within our data, what we then observe is that essentially the darker blue it is means a lower poverty rate, and the lighter blue it is a higher poverty rate. There is a greater, as the poverty rate goes up, the share of black individuals with low access also goes up, but the same is not true for that of white half share, of the share of the population that is white at a half mile low access. So I think this is an interesting way to be able to demonstrate potential disparities in food access across different populations and different demographic and racial and ethnic groups within the U.S. that might be able to inform us about how we can try to leverage where a person's location and the overall accessibility they may have within that location for food, which is really perhaps a very important variable in regards to understanding how well a person can care and rehabilitate themselves after injury. Alright, so that concludes this tutorial. I hope you found it interesting and another way to be able to leverage government open accessible data with your own zip code data. And I'm thinking of potentially also expanding into other tutorials and other data sets such as the census data within the US. And so if you're interested in that, just let me know and leave a comment and I'll be happy to do that. Alright, thanks again. Bye.